Okay.
What is WI? It's a suprema of h of x, which is f composition. So it's like which is f of g of x. Okay. Which is f of g of x, where x is in the interval xi minus 1 and xi, and this guy is infimum of f of g of x when x is running between xi minus 1 and xi. Okay. Okay. Just think about it. Where is g of x? So if x is in xi and xi minus 1, so it's a part of A to B. So where is going to be g? So g is going to throw these values into C basically.
Yes.
Into C to D. Okay. And for C to D, we know something. That for all values of C to D, K is bigger than the difference of the supremum and infimum actually. Okay. So can we say that this guy is going to be smaller than
G. Yes.
this guy is going to be smaller than K because the g of x is in C to D, and K is bigger than the supremum of f of x. Whatever could be x, doesn't matter. Okay. And x could be any instant in C to D, and K is bigger than the supremum and the difference of supremum and infimum. So in other words, I can treat this as some instant in C to D. I can treat that as some instant or some point in C to D. Since K is bigger than all basically points, so it's going to be in particular bigger than this difference as well. Okay, so that's the one thing that we included. Okay? But is there a restriction over there?
No, sir.
There is no restriction there. Right? And J is
So can you replace WR minus you different WR minus small WR?
and okay. Right. Yeah. Makes sense. Yes. थोड़ा सा सोचो तुम्हारे में सोचो. We haven't used this thing. Just think about it. We haven't used this at the moment. अभी तक इस्तेमाल नहीं किया है सब. ये तो नहीं इस्तेमाल. Just think about it. Which is the suitable place where we can use that basically. So is it going to be the I or the J? It's going to be I.
Yes.
It's going to be I. Now just think about it. So you have a difference less than delta. For this difference, this inequality would be true. Just think about it. Put mi here and small mi here, so it's going to be less than this guy. So in other words, my point is this, that this guy is going to be smaller. Each of this guy is going to be smaller than epsilon over b minus a times the sum of xi minus 1, where I is in I, plus, while on the other we are going to use what? J, because this is in general. So in other words, you're gonna have k times of sum of xi minus xi minus 1.
Yes.
Okay. And do we have 2 there? Yes, we do have 2. Now, what is this then?
Yes.
My thing that this guy is smaller than b minus a. This whole sum, because b minus a is what? Just think about it. If I take the sum of xi and xi minus 1, running from 1 to n, what will be the output? The output is going to be b minus a. Just think about it.
Some will. Yes.
It's a telescopic sum actually. So you can have b minus a. Now, what if I replace this I equal to 1 to n by this IRJ? Is it going to be equal to b minus a? Now, since you have the fewer points, it will be equal, but it should be less than 1.
Yes.
And so similar thing is basically going to be true for this as well. Now, if this is the case, then give me an estimate on the last expression. What would be the estimate on last expression? So the estimate on the first term is going to be epsilon by 2. So it's like b minus a multiplied by b minus a, so that will get cancelled. Plus, how about the other one?
So give me this summation I xi minus 1 is less than delta upon 2.
What?
The expression that is written on
Yeah. Here we are going to use basically this because just think about it. But what we can say actually then this is going to be k times delta by 2k and k will get cancelled. Delta is less than epsilon, so everything is smaller than epsilon. So you see that we use almost everything. And the proof. So it's a clear proof. It's a bit involved proof. It's fun to do. Now you're gonna see the payoff of this proof basically. You're gonna see that it's giving you some of very beautiful properties actually, very beautiful properties. As I said, okay, one thing I should explicitly mention that here I have written xi and xi minus 1, but you can replace them with alpha of xi and alpha of xi minus 1 by mistake, and then everything is going to be the same. Okay. ठीक है but not great for most not sure.
Down.
So personally, I don't like this way of presenting. It's just mechanical way actually. Doing mechanics. We're not seeing pictures actually. Okay, where everything fits in. So on picture, where is delta? Where is k? And where is sometimes there is no other way people do it except doing this. Maybe Walter Rudin would be explaining this, or he would be giving something. Like an idea of that. How much time do we have? We have some time. That's an inequality. So let's prove this inequality. A to B F B alpha is less than or equal to integral of absolute of F B alpha onto B. Where F is an integrable function. So in other words, this integral makes sense. What should be the first step? So establishing the inequality should be the second step. The first step should be, does this make sense? Does this make sense? In other words, is absolute of F is integrable? You think so? And you are okay with that? Yes.
We'll have to check if it is continuous or not.
It is. It is. So consider g of x. Think about equal to absolute of it's a continuous function.
The F is integral.
And it's integrable. So what is going to be g composition f? G composition f is going to be g composition f of x. So it's going to be absolute of f of x. And from this I can deduce that my integral is absolute of f is also integral because this composition is integral. So you compose a continuous map with an integrable function. Okay. Then we should have it. I'm still thinking about this proposition. How and why? Let me write it formally. Rather than just writing it like that. Okay. Now since f is integrable, and g of x equal to absolute of x is continuous. So g composition f, which is going to be the absolute of f, roughly integrable. Okay. Why the rest of proof is very easy. Just give me the proof for this inequality. We have done everything that we should be able to prove this inequality. One hint is that, okay, just see the previous proposition in the last lecture that we did. Just open it and just have a look.
Composition of the function is negative and g is continuous. So that gives result absolute of
No, obviously that's settled that it's integrable on A to B. I'm talking about now the proof of inequality. What should be done with the?
Sir, it is like infinite sum है हमारे पास practical inequality work कर रही sum of
It's a very good intuition. So it's like you have this, you can write this as a sum. You have the triangle inequality, okay? But okay, you can try it from there. You're gonna see some troubles like that. You can do it. There are
I was just having intuition of this.
but intuition is correct. Yeah. How about
Sir, again the integral of f from a to b equals 3
Acha, what is the relationship between f and evaluated at x? And how about this is bigger than or equal to? If this inequality is true, why we are done with the proof of that? So we did last time a result which said that if f is less than or equal to g, then the integral of f is less than or equal to the integral of g. So in that sense, we're going to say that if this is true, then the integral of this from a to b is going to be less than or equal to the integral of this, and the integral of this is going to be less than or equal to the integral of this. And this is what? It's just this inequality. Yes.
Sir, this one is correct.
So it's a completely different approach. Then f plus g is integral.
Yes.
And it's saying consider a function h of x which is
X square.
x squared.
The output f.
And then compose h, now that's a continuous function. So compose h with, f plus g, you're going to have what? F plus g squared. So the matrix is going to this is.
And then
Why this is true? It's true because of basically the result that we did last time, that if f is less than or equal to g, and you need to keep this thing in head. When we say, okay, it's a good point that you should reflect on. So we know what is the meaning of two numbers being equal. But what is the meaning of two functions being equal? It means that on their shared domain, their values are same. In other words, f of x is equal to g of x for all x.
and
Whenever g both make sense. And when I'm saying f less than or equal to g, I mean f of x is less than or equal to g of x for all x on the shared.
and that domain. Yes.